All right, well, we saw in the first part how we can use the pattern recognition to solve integrals. Now, with a formal change of variable, we completely rewrite the integral in terms of another variable. In most cases, we'll use the letter u. Sometimes when you have to do this technique twice, you also will do it in terms of v, as the other variable. But this is actually very helpful. So with a formal change of variables, as I was saying, we completely rewrite the integral in terms of a variable, which is often u, and du and like I said, sometimes we do it with variables v and dv. Now, this procedure can be more lengthy than pattern recognition, but it is definitely useful for integrals that are very difficult to do by simply recognizing a pattern. So typically what happens is that if u is equal to, let's say, g of x, as we were doing in the first part, g of x is like your inner function still, then du, the derivative, instead of writing u prime, you could write du, and that is equal to the derivative of g dx. Now, this becomes very useful. Sometimes I will just write u prime instead of du, but it's definitely useful to keep the du in there, because it reminds you of which variable you integrated with respect to. So what do we have when we do the change of variables? What we have is that the derivative of the composite function f of g of x times g prime of x dx is equal to, when you do the substitution, since g of x we said was u, is equal to f of u du, because g prime of x dx is equal to du. So it's equal to f of u du, and this is equal to f of u, the antiderivative f of u plus c. Remember, this capital F is the antiderivative, this lowercase f's are the function that we're dealing with. And this was something that I mentioned in the first part of this lecture. So let's see how this works in action. So let's say somebody comes up to you in the train, let's say at in Grand Central Station, and they tell you to find the antiderivative of the following. Radical 2x minus 1 dx. Now, the first thing that you should do is recognize the inner function. So the inner function is g of x. So g of x is going to be equal to 2x minus 1. The outer function, f of x, is the radical itself. So it's radical x. Now, because we're saying that we're going to call g of x u, then what do we have here? Du, the derivative of g, so du, remember, du is the derivative of the inner function, so du is the derivative of g prime is equal to 2. This is the only time that I'm going to do this in this way. So 2 dx. When you take the derivative, you'll add the dx. So let me just rewrite this. So this is du is equal to 2 dx. So notice in my problem, I have f, I have g, but I don't have du. Meaning I don't have the derivative of g. I don't have a 2 here. So much like we do with the change of variable, with the change of variables, I'm going to introduce it in there. But how am I going to introduce it? I'm going to solve for dx. So what I'm going to do here to solve for dx, because I'm going to substitute this dx in, I'm going to divide by 2 on both sides. So I have that du over 2 is equal to dx, and I have my complete substitution. So this is gonna take care of that constant that's missing, because now I have the 1/2 that I need. So what does my problem look like now? Well, the integral of 2x minus 1 dx with my substitution is now equal to the integral of the square root of u, because remember u is 2x minus 1 times 1/2 du, because 1/2 du is equal to dx. So now I was able to substitute this whole piece and this whole piece. Now, using the constant multiple rule, I could take the 1/2 out, and I have the antiderivative of the square root of u du. And this now is a very simple integral, because it's like taking the antiderivative of radical x dx. So this is 1/2, and remember the antiderivative of radical u is the same thing as the antiderivative of u to the 1/2 power. So if you recall, that was u to the 3/2 divided by 3/2. And again, plus c, because this is an indefinite integral. This is 1/2 times 2u to the 3/2 over 3 times 1/2. So the 2's cancel out, and you get u to the 3/2 over 3 plus c. But the problem was given to us in terms of x. So this problem was given to us in terms of x. So we have to give it back to the person who gave it to us in terms of x. So we now rewrite in terms of x. This is something that you should always do. When you give your phone to somebody to take a photo, you don't want them to drop it and give to you a phone that's cracked. So you always give back to people the items in the way that they gave it to you, or at least you try. In any case, u was x squared, u was 2x minus 1. So this means that we have 2x minus 1 to the 3/2 power over 3 plus c. You don't have to rewrite this in terms of a radical. This solution will suffice. Okay, so this is how you do a problem using the change of variables technique. You find the inner function, you let that be equal to u, then you take the derivative, and then you solve for dx, always solve for dx, and then you substitute. Once you substitute, if you need to use the constant multiple rule, use it and take the constants out, and then integrate as you normally would. Okay, let's do another one. This was example. Okay, this is example number 2. All right, let's do another one. Say now we're asked to find the antiderivative of x times 2x minus 1 dx. This is going to be a little bit different, because now notice that we have a variable on the outside. So we have a variable times the radical, or a function times the radical. In this case, our u, our inner function, it's still 2x minus 1. Okay, that's still going to be our inner function. Our outer function, our f of x, it's still radical x. What you need to worry about now is du. What is du equal to? The derivative of u is 2 dx. 2 dx. And when we solve for dx, we have to solve for dx. We're going to get du over 2 is equal to dx. But notice, I have a value to substitute in for 2x minus 1, which is u, and I have a value to substitute in for dx, which is du over 2. But I don't have a value for this x out here, and I need to find a way of writing this x in terms of u. So we need to write x in terms of u. And what we can do is focus on this equation right here. This equation says that u is equal to 2x minus 1. So if we solve for x, we're going to have rewritten x in terms of u. What do I mean by that? Well, I mean the following. Here you could add 1 on both sides, and you'll get u plus 1 is equal to 2x. And if you divide by 2 on both sides, you get that u plus 1 over 2 is equal to x. So now we have found a suitable substitution for x in here. And then we can proceed with a substitution. So we had x times radical 2x minus 1 dx. We have a value to substitute for x, a value to substitute for 2x minus 1, and a value to substitute for dx. So let's do that. So this is equal to u plus 1 over 2 times the square root of u times 1/2 du. I'm just using all of the substitutions that we had. U is equal to 2x minus 1, du is equal to 2x, 1/2 du is equal to dx. So we do the substitutions, as you can see there. Now, notice that I have here a 1/2. This division by 2 is just a half. So I can actually factor it out. This is just 1/2 times u plus 1 times radical u times 1/2 du. I just simply took out this 1/2 in the first term. But now I have two 1/2s. So I can multiply them and take it on the outside. 1/2 times 1/2 is 1/4, and I could move it on the outside. So I just multiply this by this and then took it to the outside. And on the inside I have u plus 1 times u to the 1/2. Let's write it as 1/2 so I could multiply. 1/2 du. And now we can distribute this. So notice that I'm going to distribute and simplify this as much as possible before taking the antiderivative. So when we multiply u in here, we're going to get u to the 1 plus 1/2 power to the 3/2 plus u to the 1/2 power du. That's just by distributing. And now when we take the antiderivative, we're going to have 1/4 times, again, the antiderivative of u cubed, you're going to have 3 over 2 plus 1. So the same thing as 3 over 2 plus 2 over 2. So you're going to have u to the 5 over 2 times 2 over 5. Remember, just multiply the reciprocal, plus 2u to the 3/2 over 3. We have done this one a lot, so you should know that by now. And now, remember, plus c because it's an indefinite integral. And now you could multiply in. So you could multiply in the 1/4, so you get u to the 5 over 2, and then the 2 and the 4 cancel out, so you get a 2 here, so over 10 plus u to the 3/2, and then again 2 over 3. The 2 cancels out, and you have 2 times 3, which is 6. And then finally, plus c. Don't forget to rewrite in terms of x. So u was originally 2x minus 1. That's what we had all the way up here, 2x minus 1. So we have to give it back to the person in terms of x. So 2x minus 1 to the 5 over 2 plus 2x minus 1 to the 3/2 plus c divided by 6 divided by 10. And that is the solution for our problem. So notice that this would have been a much more difficult problem using the pattern recognition method. It would have been a much more difficult problem because you may not have realized that you have to do this substitution here. Because if you think that you could just add the 1/2, you're going to have the 1/2 times 2, like we did before. Well, you have that x on the outside, so you have to worry about that. Okay, let's do another one. So example number 3 of change of variables. Let's say now you go all the way to 42nd and in times square, and somebody tells you to find the antiderivative of sine square of 3x times cosine of 3x dx. Here, we gotta think a little bit. What is our outer function? Well, notice that the sine x is being squared, so you could rewrite sine squared to a 3x as sine to a 3x, the whole thing squared. So we can clearly see here that our outer function is simply x squared. That means that our inner function, or our u, is going to be equal to sine of x, of 3x. Sine of 3x. Okay, so what is our derivative? What is du in this case? Remember, the derivative of sine, we're using the chain rule, sine of 3x is going to be cosine of 3x times 3 dx. This is using the chain rule. The derivative of sine times the derivative of the inside, which is 3. Now we could solve for dx. Notice that here we have cosine of 3x dx, and here we have 3 cosine of 3x dx. So let me rewrite this. This du equals 3 cosine of 3x dx. So we have this piece up there, but we have an extra 3 here. So let's divide by 3 on both sides. So we have du over 3 is equal to cosine of 3x dx. And now our substitution is basically perfect, because we have our value to substitute cosine of 3x, which is du over 3. We have a value for sine of 3x, which is u, and we know that our outer function is x squared. So what we have here is, when we do the substitution, we have the integral of u squared times 1/3 du. And when you begin to get the pattern, you'll see why I'm doing this. So this is going to be 1/3. You take it on the outside. This is 1/3 the integral of u squared du. And then again, you take the antiderivative. This is 1/3 times u cubed over 3 plus c. This is going to be equal to u cubed over 9 plus c. And remember, u was sine of 3x. So this is sine of 3x cubed over 9 plus c. And again, you could check your solution by taking the derivative. If you take the derivative, the 3 is going to come down. And then you're going to have to worry a little bit about using the chain rule again. So if you want to check, we will take the derivative with respect to x of sine of 3x cubed over 9. So here we're going to have to use 2 chain rules, because what we really have is we have sine of 3x cubed over 9. So when you take the first chain rule, you're going to bring that 3 to the front and minus 1. So that's going to be 3 times sine of 3x squared divided by 9. But then remember, you have to multiply by the derivative of the inside. The inside is sine of 3x. But the derivative of sine of 3x is cosine of 3x. But remember, for sine, you have to do a chain rule, because the derivative of sine of 3x is cosine of 3x times 3 by the other chain rule, which is what we had done before. So this is equal to 3 sine square of 3x times 3 cosine of 3x over 9. But notice that this is a 3 times 3, which is 9. So this the 9 on the top is going to cancel with the 9 on the bottom. So we have sine square of 3x times cosine of 3x. Notice that I didn't even bother to add the plus c, because we know that that's going to go away. And this is what we began with. This is the antiderivative that was given. So this certainly is the correct solution. So you should always get into the habit of checking your solutions, because they're not that difficult to check, because you just have to take a derivative. So there are some guidelines for making change of variables that you should know. And they are as follows. The first thing you want to do is to choose a substitution u equals g of x. Now usually, not always, but usually, it is best to choose the inner part of a composite function. Usually. When you get to Calculus 2, you'll see instances of which this is often not the case, that you choose the inner part. Second thing you want to do is to compute the derivative of u, which will be the derivative of g dx. Third thing is to rewrite the integral in terms of u. And fourth is to find the integral in terms of u. 5 is to replace u by g of x to obtain an antiderivative in terms of x, which is how it was given. And last but not least, check your answer by differentiating. I also want to check your answer because you may make mistakes along the way. The next part of this lecture, I will be talking about some more rules of the change of variable technique and some more rules of anti-differentiation that will be useful to you if you do need to go into Calculus 2. Also for the final, this is all stuff covered on your final.